Hello and welcome to the first of the data science webinar series. Today's session is Simplifying Time Series with DataRobot. To note, we have some exciting topics coming up in this series that can be found on our website, such as how to select a model for predictive analytics, prepping for predictive, overcoming model failure, and much more. A few notes before we get started. This webinar is being recorded and the recording will be emailed to you in the next few days. We will also be opening up the webinar for questions at the end, but feel free to submit your questions in the Q&A panel as we go along. A few introductions. My name is Rachel Mason and I'm the marketing specialist here at Teknion Data Solutions, and Technion is happy to be putting on these webinars. And without further ado, I'm going to turn it over to Teknion's data scientist, Dr. J. Kyle Roberts.
Well, hello, everyone. This is a kind of a new way for us to do it. And we decided today that since we're all experiencing COVID at home, we would start to put out some more webinar series. And so the one today, I'm definitely going to love bringing to you because in truth, time series is difficult. And it's hard to get a good grasp on how to run time series, how to interpret time series. And I like how DataRobot has thought about this and the thought they put forward. I just want to give a little background on myself. I've been with Technion for 2 years now. And before that, I held professorial positions at Southern Methodist and then also Baylor College of Medicine. And before that, University of North Texas. Most of my research has been, though, in using R. And so I know many of you are familiar with that. I co-authored the Y-Hat package therein. And mostly a lot of this had to do with both regression and multi-level analysis, or sometimes called hierarchical linear modeling. And inside of that, I was especially excited about doing time series in a multi-level framework. And the reason is that I often found time series modeling procedures like ARIMA or doing an AR1 structure or ETS. I found them to be rather cumbersome and burdensome, and I liked the amount of flexibility that I had within a multi-level framework for doing this, okay? And so here's why I want to bring this out just at the very start. So you're going to see a lot of models that you probably wouldn't think, oh, that's a actual time series model, so like ridge regressor and things like that. That most of us have done time series before. We're used to seeing either ARIMA or ETS, and that's about it. So, and here's where I want you to really kind of open up and broaden your thinking in this area. Time series really is just a extrapolation of what we in stats call the general linear model. And so there is, if you want to think of this being like a pyramid or a tree, at the very top we have the GLM, and then everything kind of comes down from that. I guess right under it we'll probably put structural equation modeling, and then below that maybe multi-level analysis and canonical correlation, and then special cases of those being like factor analysis or principal components. And then also regression and ANOVA, and then you get time series as part of that too. And so it's really helpful to think of, look, most of the time, especially ARIMA and ETS is really just a special case of multi-level analysis. And so once we recognize that, we can do more complicated models. It just requires a stronger coding and coding skills. Now, the thing that DataRobot has done is they've taken all of that the expertise required to do the really high-end coding skills and remove that from the equation. So it's not near as difficult anymore. And then you'll see that even a citizen data scientist or even an analyst can now run time series, monitor models, things like that inside of this package. And so that's why I'm really excited. And this is the first thing we're doing to kick off in this series, is this type. So let's talk just a little bit first about what time series looks like in time series data structure. More often than not, if you are working with an analysis, with data, you probably have something that looks like what we call in the top, though, a wide data set, where let's say a column represents each time point in your data, which, and this is nice too, because when you have data that's feeding into a data warehouse, you can just say, okay, let's put a new column on there every time, at the end of every day when we shove data out into the data warehouse. which is great for storing and those type of things. But for an analytic structure to feed into most all of your data packages, we actually need it to be in what's called long format. So we need to do some sort of transpose or, pivot on that data to pivot it down to where this lower part, this long data, our data look like that. So the reason I say that is I'm going to show you some data here in just a second. And as we look at that, you're going to see it all in this long format, because in order to enter that into most analytic packages, we need this in this long data format. Now, again, to transposing it from the wide to long, really pretty straightforward. In fact, for those of you that are users, it's literally the command T. That letter, small, lowercase t, and we'll pivot that thing down, okay? So that is something to consider. And then, but the other thing that I think is interesting to consider is that when we're typically talking about the different types of time series models, again, ARIMA is the one that you probably think of the most. And it's typically used when you're doing your future forecast. It really all depends on the most recent observations. And then ETS on top of that that's typically used when you see, all right, hey, there's a strong seasonality trend in the data, okay? So are there other models that can kind of get the best of both worlds? Absolutely. So we can do something like growth mixture models or something like that would give us the best of both. Okay, so we notice the seasonality, but there's also a trend in there. But here is the problem with both the ARIMA and the ETS. Let's suppose you have signal coming from multiple sites at the same time. And so let's say you're doing retail sales and you're wanting to look at the sales of a specific item, but you need to recognize that some of it's coming from stores, let's say in the Northeast, others is coming from stores, let's say in the Central Midwest, something like that. And so you do have all these sales, but you want to model them all at the same time. And so that gives you an idea about how that item is functioning within the stores, but also gives a dependency to the stores. Well, typically you would need to do this in a multi-level framework. It's really difficult to do. And then if we think of that even further, in that we have, let's say we're doing a time series analysis with children in schools, and across years, we're noticing that children are actually let's say all of them started at one middle school, but then when they went to high schools, they moved to different high schools. So every student in one middle school did not matriculate up into the same high school. And then also kids sometimes move within a year. Okay, now we've got incredibly complicated data. And so we usually call that multiple membership modeling. And again, ARIMA and ETS just won't do this, a multi-membership model. And so what we're looking for is a package that will, in essence, let us do a lot of these more complicated type analyses and run them with relative ease. And so, again, multi-level time series. Now, this thing that I just talked about, multi-level time series. It's somewhat available in DataRobot. It's kind of one of their newest features in here. And so DataRobot's going to identify this as a series. But here's the important part, is that we can include covariates in this model that, let's say, do change over time or maybe don't change over time. And I'll show you examples of each of those, putting in a covariate that doesn't change over time, like let's say location of the store, versus one that does change over time. Let's say like whether or not that day's a holiday or something like that, okay? All right, so I do want to put this out as a great resource, and so I try to kind of add things as we go. This is easily my favorite book in doing longitudinal data analysis or time series analysis. It's by Singer and Willett, and actually I don't know John Willett well, but I do know Judy, and she's an outstanding researcher, and so this book highly recommend if you're wanting to. It's not on incredibly detailed level such that you do have to have a stats background in order to read it, but I think it's a really easy to pick up. So I used to use it with graduate students in education who didn't have a huge stats background, and they really enjoyed it. Easy to read, easy to interpret, easy to understand. So anyway, this is a really good resource for that. So just wanted to put that out there. All right, so what about DataRobot that we're going to look at today? So DataRobot, first came around in 2012, and just have kind of an interesting story about them. for those of you that have played around in Kaggle, so Kaggle is a place that will they will put up, it's almost like a competition for people who are interested in analyzing data. And so Kaggle will every once in a while put up a data set and say, all right, there's a competition for, let's say, $50,000 to who can analyze this data in the best way, in the fastest way, with the most accurate algorithm. And so let's say I'm a company, I say, hey, I need to build a really good model for my stores or something along those lines, or let's say modeling something in healthcare like a probability of readmittance or something like that. So I could put all my data up there. It would be made available to the public, and then there would be this big competition, and people would win this, and there's leaderboards and all sorts of stuff. Well, goodness, in around 2014, 2015, we started noticing that in Kaggle, these people would make it to the top of the leaderboards, and then they would just somewhat disappear. What had happened was DataRobot was hiring a lot of these people to help build this suite of tools. And so they were obviously recruiting from, hey, who's the best at doing this in Kaggle? And so they all kind of got together. And so it is currently has, in fact, I know that number is not as high as it needs to be because the funding to date, because I know they just got a recent new round of funding, and they're having millions of models built even every day. Okay, so 200 plus data scientists and engineers, and they have footprints in the places that you would expect a really good package like this to have. So 8 out of 10 top US banks and 8 out of the top 10 largest companies in Japan. And here's just a couple of places that you can see that, even consulting companies like Deloitte. But yeah, a lot of insurance, healthcare, banking, and finance is a really big place that they're in. And so we're talking about really massive deployments where they're starting to make a good footprint. Okay, so that's just a little quick primer on DataRobot. And so what I want to do now is actually switch out of here and let's talk about the data that we're going to be analyzing today. Okay, so I'm going to actually show you 3 different data sets. I'm going to think we have plenty of time to do each one. This first one is just really, really simple data. So let's suppose that we are looking at this data set that is just has dates and it has sales of a specific item in our store for every day. Okay, and so so we have over on the left, we have our calendar dates. And remember, we talked about that this needs to be in this, not the wide format, but the long format. So we had this set up, it's already in there. And I'm going to be looking at data from 2013 all the way out to 2017. So it's a pretty strong signal that's going to come through. But DataRobot, when we first open DataRobot up, we're going to get a screen like this that's going to allow us to load our file in. Now, again, if we are just going to drag and drop our data in here, but we don't have to do that. So we could actually create to link to live data that's coming in, and we could from our data warehouse, and then we could set up from that source that we have, data pushes across every night. DataRobot runs in the background, analyzes it, gives us new updates every night. But for the purposes of today, I'm just going to drag this data in. So here's this time series. It's one item in one store. And literally, as I drag it across, DataRobot will start reading it in. So it's going to work on the raw data for just a little bit and analyze it, make sure we're seeing what type of data set that we think we're looking at. And so as it's reading the raw data in, it's going to do a quick exploratory data analysis on it, give us some information back so that we can kind of do some checking on the data before we move forward. And so as this is finishing up, you'll see our status bar here over on the right is going to say, all right, the data is coming in. And then once that data is read in, as it is now, it's going to allow us to do some things with the data. So we'll start with down here just looking at that I have here are my 2 measured variables. There's sales. And if I click on sales, we get an idea of here's a histogram for the sales across the entire data set. And so we have scores, if you look at up here, from 4 all the way up to 50. So unit sales per day with an average of 19.97. Okay. And so as we're looking at all those scores, we can see, again, this is just a histogram, so laid out of that. And then we have our other variable here that is the date. And so we look at scores from, as you see on this, January 1, 2013 to all the way to December 31st, 2017. Okay, so that's where our data are. Now, one of the things that DataRobot has already done for us, which is really nice, is some feature engineering. And so we didn't, remember, this wasn't in our original data set. We just had two variables in there, but DataRobot already took this date variable and parsed some of the things out to do some feature engineering for us. So the first is that it pulled out the day of the month. So that's like 1 through 31 or 1 through 30 or 1 through 28, depending on what month we're in. Okay, it also pulled out what month it was, the day of the week, which we're going to see is actually going to be pretty important for us, and then the year. Okay, so I pulled out those features automatically. We didn't have to do any extra coding. That's already in there. Okay, so I'm going to take this sales and I'm going to put this as my target variable. I can either do it down here or I could actually do it up here. And so it's recognizing that my sales score is fits. It's not a classification, so it fits in the regression model. And then I'll set up time series modeling over here. So I will select there, and it already looks at it and it says, hey, I've already seen that there is a date variable inside of your data set. And so we'll select that. That date variable as the variable to use to do the time series. Now we're going to see some really interesting, cool little plot that's going to be put up real quick for us. And so it just takes a second to come, but you're going to see there's massive seasonality in this data set. And again, this is just a fake data set that I made myself. But as you see, the data is coming across here. Each, if you will, rise and fall kind of represents 1 year's worth of data. So there's from this spot to here, that's about 2013. There's to about 2014 to 15 to 16 and then to 17. So a lot of seasonality trend in here. So we should be able to pick up on that. And so now we want to do, if we actually want to do the time series modeling. I'm not going to talk about out of time validation, but we are going to want to actually treat this as a time series model. Now, here's the great thing about how we're doing, how we're setting up this data, or how we're going to run the models and then doing back testing and things like that. So this is where we actually would want to spend a bit of time. So what is happening is DataRobot is using, in this case, we're saying take the last 35 days to derive features. And then in that, once those features are derived, we really want to forecast forward from 1 to 7 days. Now, this is going to determine what our back testing looks like. And so in that, we'll do the number of back tests we do. It'll take really those last 35 days, forecast 7 days into the future. Now, why is this important? So let's suppose we actually have, we don't have regular just sales data coming forward, and we're wanting to forecast, let's say on Sunday, we're wanting to forecast the next week worth of sales. Let's suppose we're trying to figure out customer volume in a restaurant. And the reason we want to know that is because we're trying to predict that into the future, because we're trying to get a good idea of how many people we need to have on staff. Okay, so knowing that when you're doing staffing, you would release a staffing structure, let's say for the next 2 weeks, but it wouldn't be for that Sunday. You would actually be for the following Sunday and the 2 weeks after that. A really nice feature is we can say, hey, go out to day 21, but start on day 8. Okay, so in other words, when you do the predictions, skip this week, because that week we already have our staffing set for that week, and then go 2 weeks into the future and predict out 2 weeks into the future. Okay, I think the maximum number of days, I'm not certain about this, but I think the maximum number of days we can predict in this type of modeling is 30. I'm not quite certain about that, but I think that is right. But for purposes of what we're doing, we're just going to go 1 to 7. Okay. After the forecast point. Now, I do want to show you a couple of other things. The first is this features known in advance. I'm going to leave that alone until our next until we look at our next data set, but then also show you that here are some great advanced options where we can look at how the back testing is doing. So right now we're going to do 4 back tests. There's going to be 1 holdout that we can actually put in later on. We can release that holdout at the end, okay? But we're going to do 4 back tests, which means on this first back test, we're going to take data that starts in, it looks like November of 2013, goes all the way out to July 1st, and then uses that information to kind of predict forward. Okay, and so and you'll see that's where we're going to backtest. So in all of this, in other words, in this first backtest, we're going to use all the data in the blue to do some modeling on the data that's in the green. This is going to give us a good idea about how our model is functioning. Now, in this, the reason I like 4 backtests on this, because you think of this is a 3-month period, a 3-month period, a 3-month period, and then a 3-month period. And so if we multiply 3 months by 4, that's a full year's worth of backtesting, okay, that we're doing on our data set. So that's a really good idea, really good model. Okay. All right. So having said that, now all we do is we just hit the start button. I'm going to leave it alone from there because we've got a lot more to get through. And really what's going to start happening here at the very first is that DataRobot is going to start looking at our target or our outcome variable and derive a ton of time series features based on that. Okay. What I'm going to do right now is just up the number of workers. This is basically parallel processes that are running. So the next thing at DataRobot doing is pulling up these time series features. So it's deriving them. And we're looking at, so as you can see, as each of these are coming across, the first one is a sales log difference, meaning a 35-day median. And then here is a good idea of all of these that are being built. So some of them are taking the log of those. So the 7-day difference in a max 7-day, or looking at a 7-day difference on a 35-day minimum. So at least 35 days out. Okay. There's some other ones like a 4th lag. So what that is that's just going, go back 4 days and use that information in order to predict forward, or 7-day difference with a 4-day lag. Again, so all of these are being automatically computed for us. And as they're being derived, what DataRobot will then start doing is saying, okay, which of these tend to, or are showing us really good information in the data. So although a lot of these are derived, so it looks like right now we're up to 115 derived features. It's not all of these are going to be useful to us. And so what we'll do is, even though DataRobot said, all right, there's 115 there, what it'll do is start creating the back testing based on these derived features, looking at that target variable, and then it's going to start building a whole bunch of models. And so in our case, as these models are being built, we'll see them appear up here in this models category. Now, again, all of this stuff is done in the background. And for those of you that are really familiar with time series, you'll know that this is the part that takes a ton of time if you're starting to do your own. So now DataRobot's already found some stuff that is meaningful. So for example, this first one that is coming up is a meaningful feature that is already recognized. It's sales, and it's, if we look at this, we can see same weekday and on a 28-day mean. So in other words, what it's saying is that what seems to be important is what day of the week it is, meaning is it Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And this does make sense to us because in this retail situation that I've hypothesized and actually iterated or made iterated data around, really showed that this weekend sales actually is a lot greater than the weekday sales. And so this is just something I set up. And so it's of it's no surprise that this is coming up as one of the more important variables. Now, the models are being built over here. And so right now we have 10 different models. And what we're going to do is create a leaderboard, if you will. Now, the root mean square error is the RMSE. That's what is really letting us decide who is the best on the leaderboard. I don't find that quite as useful as the maze in order to look at this. And so maze is mean absolute scaled error. And the reason this is important is because what DataRobot is done is, if we get down to here, there it is it's using a baseline predictions model. So if you would think of this as this being like a naive model, and then these other models above, so we're going to set that to 1, and the other models that are being derived, this is a good way of thinking about how much better is it than the naive model. So for example, if we go up to this one that's 0.68, another way of thinking about that is it's 32%, or really kind of almost 31% better than, because 1 minus 0.68 is 0.32, so 32% better than the naive model. And so I think this is helpful to me, because when you have really bad data that has no signal, you'll find that some of these models don't do any better than just a naive model. A DataRobot here, and that's why I like using is the metric, the maze, okay, on this. So some of these models that are being built, so some of these are DataRobot specific models. If we come down here, you'll see there's a couple of XGBoost models. Here's some Python models that are being built, and you can tell because of that little icon right there. There's Python icon, there's an XGBoost icon. Okay, so we're going to Martha Stewart this though, and we're going to actually, you know, where she puts all the ingredients together and then she sets it in the oven. Then all of a sudden inside the oven, there's a done and baked cake. So I'm going to pull out the baked cake here, and we will see, all right, so here are our models, and here's kind of what we found. DataRobot, this takes probably 15 to 20 minutes to run. DataRobot found that these are some of your best models. And so I'm going to look at this one that is the most accurate model, just because I think that this one is pretty interesting. Okay. All right. So we'll start here with evaluating the, actually, I tell you what, let's start here because this is actually pretty neat. DataRobot really wants to be transparent in how the models are built. And so as you can see, this gives you the model blueprint for how the data come in, split into numeric categorical variables. The categorical variables have one hot encoding on them. The numerical data has some cleansing. They're doing a naive predictions and then letting this ElastiNet regressor actually come out of those naive predictions and then push forward. Now, if you may be looking at this going, I have never even heard of ElastiNet regressor with L2 Poisson deviance, right? If we click on this, this is a great thing. Oh, click on that again. We click on then DataRobot models. We get a full great description of what this model does and how it's derived and the code that they're using to do to actually compute this model. And then also, there's really great down here is some libraries that can let you know about, okay, what is some things on the logistic regression linear models, and then also, you know, what is an elastic net, and there's the user guide for it. Okay, so all that information is made available to you. Okay. So let's evaluate our model, and we'll look at it in terms, first of all, over the lift chart. And so if we think of the lift chart, this is a good idea of thinking of how our data is broken up and how it's doing over time. So if these blue pluses, that's our predicted score. The reddish orange scores, those are our actual values. Okay, so we can look at then, not across time, I'm sorry, across our subsections. That we can see that when we're doing a job of predicting, how well are we doing? Okay, so for the different scores. So if you think of this, at this last bin down here, scores on average, oh, there we go, are around 32, meaning 32 actual sales, and we're predicting it to be around 34. So it lets you know kind of for different values of our sales numbers, how well are we doing in predicting those. So again, as we would probably expect a little bit at the tails, probably not quite as good as we would be here in the middle, which is right, but we're really not far off. We're actually doing pretty good throughout there. So again, this is the first thing I look at to see something really bad. And then we can look at our feature fit, meaning how do our variables function? And these are kind of ranked in order, if you will. And as we saw before, this comes back to one of the most important things for us to being able to determine why our data is the way it is understanding sales and looking at the same weekday. So this is our best variable, same weekday on a 28-day mean. Okay, so in other words, what it's saying is look back 28 days and give me the average of all the Mondays, or give me the average of all the Tuesdays, or give me the average of all the Wednesdays. And that is a really good predictor of what our current sales are going to be. Now, again, to the 35-day mean, so going a little further back is not quite as good as the 28-day. That probably has something to do with the seasonality having being being somewhat month dependent. So kind of what month are we in? And that may have something also to do with when people get paid. Who knows? Okay. So I like looking at feature fit, and then also like looking at accuracy over time. And so this is a good idea to give us, again, to these predicted values versus the actual values. And so how good are we doing at predicting these spikes that we see over time? And so this is for the first back test. And so if you see looking there on the first back test, that is that period of time that we were back testing for. Remember those 3 months. And then if we wanted to actually look at all back tests, we could pull this up. And so this is a lot to read, but we can look at all these back tests, and so, or different back tests. So the reason that this is important though, is that you may want to know during a specific period of time, how are we doing? So this is kind of pushing spring into summer. How are we doing there? And then, so there may be different back test periods where you think, all right, this is the thing that I actually care about. How are we doing at Christmas time? Okay. So that gives you some good information about that. Again, as we spoke before, feature impact. So we really want to see these feature effects. And again, day of the week is the thing that is really driving the bus. And then the date, the actual month, is giving us the second most information. So, and which is interesting too, because if we just take this sales 30-day median and then sales 30-day min, the year 35-day min, that information is not near as helpful to explaining what's going on with our data as it is me knowing the actual day of the week. So in other words, think about that. It doesn't matter as much what month you are in as it does matter, so your sales for the last 30 days as it does matter what day of the week it is. And so that was a really interesting finding from this data set. Okay. So that gives us a lot of information about that data. But now, of course, we always want to go into making predictions and thinking about, all right, now that we've got our data coming in, what does it look like to predict forward? So what I did is I made just a really quick data set where I'm going to predict the next 7 days of my data. And so let me show you what that data set looks like here. So this is a 2-score data set where we have, let's say I have the last 2 months worth of data. And then I want to predict the next 7 days worth of data. So this would be a type of data set that I would push across. Is that here's my historical sales, or here are the sales for the last couple of months, and then I just leave blank down here what I want DataRobot to predict for me. So I'm going to push that data set over, and it's just a CSV file that you can literally drag and drop. Now we can put together model deployments here, where we actually have data that's pushing across from, let's say, a data warehouse. And so let's suppose we wanted scoring to run every night, or we wanted it to run once a week, or something like that. Again, DataRobot fully supports with an API your ability to do that. But just for the purposes of today, we're going to push this data over. And then here is the really great part. What DataRobot's showing me is, look, here's your data actuals for the last 2 months, and here's what we're predicting for the next 7 days. And so these are the scores that were the actual sales, and then those confidence intervals, which we could actually control if we wanted to. Around there. So this is just a graphical representation, or I could download those actual predictions if we wanted to. Okay, all right. So this is a really, really simple model. Okay, all we had was date and sales. But let's get a slightly more complicated model. So what if we had something like this? This is a time series holiday data set. So similar to the data set before, but we have this variable in there that's called, that is whether or not something is a holiday. Okay, and what I did, again, this is just for the purposes of today. Let's suppose, this would be really easy to think about. Let's suppose we're looking at sales, and we can think of that as alcohol sales. And so some sort of, the way we will say maybe these are hundreds of dollars of alcohol sales that we're seeing. And we wanted to know, when we have a holiday. So for example, here's the 5th of May, so Cinco de Mayo, maybe we're going to see more sales on then. And then if we go out to, let's say July 4th is probably a pretty big weekend, which alcohol sales would be up. And then we also did Thanksgiving and Christmas. And so we just put that those days are a yes, and all the other days are a no. Okay, so in that one's going to be a little bit different of how we would put that data in there. And so let me show you how this works. And this, again, really helpful in order to say, all right, we know some stuff that's going to happen in the future. So here is our, let's say, there's the holiday. There it is, time series holiday. So I'm going to drag this data set here. And again, we're going to do the same thing, but I want to show you how to set this up. And then we will look at the output from this, this type of model. So again, this is all reading in, and all we have is the date, and we happen to know when a holiday is going to occur. Now, again, we're not limited to these things. We can have tons of information in there, but the idea of today is just to give you a simple understanding of what DataRobot can do with time series. And this feature of being able to say, hey, these are things that I know in advance is really helpful because usually when you include this in a type of model, you have what's called target leakage. You can't include data in there that has information that you would know in the future unless you handle this in a certain type of way. And so DataRobot's already baked all of this information in so that you can set up data that is going to be in the future, or stuff that you will know about the future. So we're going to go ahead and set up our time-aware modeling. We'll set it up as time series. And again, we'll go, let's say this time we're going to go 14 days into the future instead of 7. Okay. And then if you remember from before, features known in advance, there it is. So here's what I'm going to say I know in advance. So I'm going to put in there this holiday variable. Those are things that I know ahead of time, whether or not something's going to be a holiday. Now, let's suppose we're in banking. This would make a lot of sense to us to say, hey, I know in my area people get, so I'm trying to predict deposits or how much money we'll have on hand. And I know what days people get paid on, like if it's every 2 weeks or it's once a month, or and so I can actually model that as a feature I know in advance is what is payday. So that's, again, that's just another way to think about this is, features you might know in advance. So again, we've just set this up really quickly. There's that feature known in advance. It's similar data as to before. And then we would hit the start button, let that start to run. But as you can already see over here on the right, there are those big spikes. And those are those times where we're seeing those are actual holidays. And so we're seeing each of those spikes are going to appear when we have a holiday. So I'm going to, once again, we're going to the magic of Martha Stewart. So this time series holiday, this is a completely baked in data set. Okay. Here's the 27 models that were derived. And then I'm going to look at this, this average blender one. Again, as before, we want to look at that lift chart to give us an idea about what's going on. And here's the great part. We're not doing too bad at predicting that last bin, if you will, of the spikes in our data. We're actually doing pretty well. We're getting, even though we're doing really well with these lower end areas, but when our data, our sales spike, how well are we doing at predicting those? It's not terrible. We're doing pretty well. Again, that's gamma deviance. I actually care about MACE, so I'm going to change that. So, or another way to think about that is that holiday data, though, is that right now we're doing about 57% better than a naive model, right? So that's, or if we look at all back tests, we're about 49%. But in this one, about this single back test, we're about 57% better. Okay. All right. So let's look at our feature impact and let's figure out what's the most important feature. Surprise, surprise, whether or not it's a holiday. Okay. It's just really making a ton of difference. And then we have the date as the month, and then the day of the week is next. Okay. So if we want to look at those feature effects from the variables that we derived, again, now we have a data set that really gives us a lot of information about alcohol sales, and holidays really carrying the day in this data set. What month we're in is next important, then the day of the week is third, okay? So that is a quick way of looking at that, really, really quick. And then, so let's look at a period of time where we're gonna predict something when we do actually have a holiday. So this data that I'm loading in here, let's see, the holiday to score, I'm having it go look back at all the June sales and then predict forward for 14 days. And so I wanted that July 4th date in there. So there's that yes on that holiday. Okay. And so when I do the preview of this, you'll see, yep, there it is. Here's the back testing, or I mean the historical data. And then when we get into this predicting area, so the 3rd and the 4th of July, looks like we are forecasting about 192 or 183 and then 192 for sales. And so, yeah, so that's good. That's DataRobot's picking up that information from the past. That is particularly from the future and saying, all right, we're forecasting because there's a holiday during that time that this is going to have a huge jump. Now, again, you can think of, depending on what field you're in, this is a really, really significant addition. Is that you can say, hey, I know I've got this event coming up. So let's say you're in telecom and you have, you know where the Super Bowl is going to be this year, and you realize, you know what in years past, what the usage on phones and let's say your 4G network has been in that area where the Super Bowl has been. That'll give you a good idea of the amount of resources you're going to need available in order to, to be able to carry that date or for all the phone usage during a Super Bowl or during some sporting event or something like that. So as you can think, really, really powerful. Again, doing this in other packages is really hard to do. And knowing that about the future going forward, that's really great. Okay. All right. I want to do one more type of data analysis really quickly, and then we'll try to open up for questions. This last one is let's suppose we're doing a time series, but we have one item. So we've got this item here, item number, and then we have the sales. But what's happening is that we have it coming from 10 different stores. So let's suppose the same information as before. Here's that item as sales for 2013 through 2017, okay? But then when we get down here a little bit, okay, now we have that same information coming about that same item, but now we're in store number 3. Okay? How would you handle this? Well, we could just lump them all together, but the problem is that we're probably missing that the stores actually contain a lot of information about why we're having differing levels of sales in each of the stores. And so we want to honor that. We don't want to just dump it all together and just say, all right, add up the numbers from all the stores, because the stores could be containing information, especially if you think about retail locations. So you're trying to look at, let's say, how one specific shoe is performing at your retail locations. Well, suppose it's a high-end, let's say a women's party shoe, meaning that, you know, it would be a nice patent leather or something like that, that women would only typically wear. It's not an everyday shoe. It's one that you would wear to a really nice event or something like that. Then you wouldn't expect that in rural areas that shoe is going to sell very well, but in, you know, metropolitan areas it probably does sell well. So we need to allow for the fact that this is coming from these different sources and is actually containing information. And so when I load this data set in, again, we'll go back into DataRobot and load this type of data. So we're going to be looking at this this time series and the wait, that's one store, one item, 10 stores here. That's this data set. Now it's a pretty big data set, but I think it's worthwhile just to show you how DataRobot is going to handle reading in this type of data, because it is going to be pretty important that we look at. Here's what it looks like, and again, I'll show you how to set it up, and then we'll bake the cake and stick it in the oven, and then find out kind of what happens as a result of that. Okay. So as this is pulling up, again, it's reading that raw data. This one takes a little bit longer because it's a pretty big data set. So again, we're going to look at sales as being our outcome. We do want to set up our time aware with a date, and then we will come down here to this time series modeling. And in this one, I want to say, yes, there are multiple series in our data set. Okay, so yes, this is true. And so DataRobot is going to start looking at if there's a series identifier, and I can, again, it's going to check and make sure this is right, but store number is the series identifier. And yep, it did check and make sure, yep, it's set up correctly. And so now I'm going to say, all right, set that series ID And now we can do the time series modeling based on you know, how far we want to predict out into the future. Again, all this other stuff that we were putting in before, that we can look at the number of back tests that we're going to do, whether or not there are features known in advance, those type of things. Okay. All right. So again, I would run this. This one actually takes quite a bit of time. It's about a 30 or 40-minute run on this one because it's a pretty big data set. But let's go 1 item, 10 stores and baked. And so here's our complete run. We ran 34 models. Again, look at this elastic net regressor. And here is the interesting part on this. When we start to understand the feature impact, oops, actually did not pull feature impact on that one. Which one did I do? That one's not it. Hang on just a second. I thought I had on that one. Let me, okay, actually we can do everything we need from right here. I tell you what, I'll enable the feature impact real quick while we're looking at something else, and then the feature effects too. Okay, so as we're evaluating this though, and we look at the accuracy over time, so here's the important thing to look at, is that if we're looking at these series, we're looking at it from coming from each store. Now it's hard to see just in looking at this, but what we're trying to find out is that across time, how is our data performing at predicting the changes within each series? So in other words, think about this, is there are 10 series in here. And so I want to look at within each store. Okay, so right now we're on series number 6. And again, I want to change this to MACE for later on, for something we're going to look at later. But we're looking at, okay, how well are we doing? And as you can see, that prediction and that back test period is pretty similar across each of the 7 days. So it looks like we're having this kind of 7-day jump every so often. But the data is, we're not doing amazing in series 6. But if we look at, let's say another one, here's one. That's actually even a little bit worse, although we are catching these spikes a little bit better. And that, then if we go, let's look at number 9. Again, the 9, there's a lot more volatility in that store. And so we may not be picking that one up quite as well during that back test period, okay? So now we can look also at feature fit for this. And here's the interesting part, which what we really want to know is what makes the most sense for determining our data. And we've got this interesting thing again, a sales same weekday, meaning is it Monday, is it Tuesday, is it Saturday, Sunday? And looking at the 21-day average for those and then the log of that, that's what's giving us the most information to be able to understand this data set. And then let's pull up those feature impacts. Again, store number is giving us a lot, but the date is also giving us some information. So here, if we're looking at the store number is actually driving some things. And then after we pull out the information from store number, another way to think about this is that the date, meaning the actual date, is giving us good information, and then day of the week after that, okay? So again, this is kind of a really quick, how do we understand what's going on in our data set? And then if I wanted, I could actually look at, in terms of validation, I could unlock this holdout and then look at that last piece in order to see, all right, how are we doing for that last one? This is all back test, and if we just wanted to look at back test 1, we could pull that out also. Okay, so that is a really quick, really a little bit like drinking from a fire hose. So I'll apologize about that. But we did have some questions, and I wanted to leave a little bit of time to see if one of them is, the first one is does this run on the cloud or on-prem? Great question, both. So you can either run it on the cloud or on-prem. And so there's not any difference in terms of now how DataRobot has changed their pricing structure as to whether or not you have to do that. And then it said, I got another question that said, given today's COVID-19 disruption, I would just change DataRobot information just for these heavy swings of demand and supply. Okay, that's a great question. So the question is how, what happens when you have a whole lot of anomalies in your data set, okay? The problem that you're going to face here is that nobody's going to be good at COVID-19, right? Because we haven't ever had anything like this before in data. So this would be again, where normally I would run, for me, this would be, if I'm running an analysis that is, let's say, once every month in a COVID-19 environment, I'm rerunning this analysis every single day because things are changing so much. Again, too, I don't think any model in the world would have predicted a price of, the barrel price of oil would go negative. It's just, or even down to, $5 a barrel. That's just not, it's just not possible. It's kind of, you're only as good as your data. So if you have good data, you're going to be good at predicting it. But if you don't have good data, it's not going to go well. Okay. Another question is, how much power would it require to run forecasts for, let's say, 10,000 stores selling 1,300 items? That's a great question. It's not unforeseeable to do, right? Now, again, if we're running this every night, I'm probably going to want to set up a node for it to run by itself, meaning that I'm going to have one node that's going to be set up to do just the model building and then the model production, but then I'm going to set up another node by itself, and maybe two nodes to run the prediction application every time it runs. So again, if you run it every month, it's not bad. It maybe take all night to run, or a good chunk of the night to run. But once the model building is actually much more difficult than the prediction application. Prediction application actually runs pretty quick. So I would think 10,000 stores at 1,300 items, forecasting those, you're probably getting that in a few hours. It wouldn't be bad at all. Like for me right now, just giving you an idea, I was forecasting, so let's say 365 times 5 days or 5 years, so let's just say let's call it round at 1,600 or 1,700 predictions. It's going to take maybe a few seconds to run on that. So not bad at all. It's really quick, and it also is kind of with most stat software, then it really is just throwing more servers at it, if you will. So another question though was in this, I'm going to let this be the last one because I want to return back to one other thing to make you aware of, and so that I think you're going to be very excited about. Does DataRobot automatically do feature engineering? Yes, it does. It does it out of the original data set. And then maintaining a data dictionary and data lineage, there's not much information there. However, I was talking to one of the DataRobot engineers about a month ago. This is very much on their radar as to how does the metadata push through, and then what can be done with that. And so you can get that information out of here. It does take a lot more effort than just saying, hey, give me the metadata pass through and all the changes that we're having in the data. That does exist. It's just really difficult to pull out. And so you have to, that's when you get a DataRobot engineer and they come alongside. So yes, in terms of data governance, you can do this. Okay. All right. So I need to stop right there because we've got just a few more things that I want to address. And so let me run back to the PowerPoint because I think this is going to be pretty exciting for y'all. So let me play from current slide. So the first is this. One of the things we were able to secure recently is that DataRobot now has a free trial program. This is brand new. I mean, hot off in the press in the last week and a half or so. And so let's suppose you would like to, before, if you wanted to just play around with DataRobot, you did have to get a complete POC going, whereas now they're recognizing, hey, it would be nice if we had kind of a 2-week trial. And then the great part about it is that, so all it takes is if you contact us and say, hey, I would really like to do a demo, the 2-week demo, then we will get you in the contact with the right person. So you can email me and find me on the Technion website and say, hey, I'm really interested in doing 2 weeks. It takes about 30 minutes to an hour to kind of get you oriented and set up. And then you can play with the data all you want for 2 weeks. Okay. Now, not everything is turned on this, but most of it is. And then they also have some great free data. Like if you're interested in hospital readmission, they have data set and they already there, so they can show you how to do that. Or if you're doing predictions for fantasy football, or you're wanting to do predicting early payment of loans, or let's say probability of default, there are some baked in data sets in there that you can use in this. And so again, if you are interested in getting a 2-week trial, please reach out to me or any one of us, I mean the salespeople here at Technion. We will get that set up for you, and then would love to walk alongside you during that time. And I think, boy, if you're like a lot of our customers right now, we've got some downtime. So, but then the second is that we have some more webinars coming up. And so I'm going to turn this back over to Rachel, and she can talk about some of those webinars that are coming up. This is a screen capture from our website. So Rachel, the rest of the time is yours.
Thanks, Kyle. So yeah, like Kyle mentioned, we have launched a new webinar series called Technion's Client Solution Webinar Series. This can be found on the homepage of our website. Within this series, we have 4 major topics, one being data science, including today's session, another over data pipeline, another over data strategy, and another over visual analytics. So be sure to check out upcoming sessions that can be found on the pages within there. And then again, just to kind of wrap up everything, we hope you enjoyed today's session, and we'd love to continue any conversations, whether that's about DataRobot, or if you have more questions for Kyle, feel free to reach out to us and be looking for that follow-up email with the recording. Thanks so much for joining us today.